Hi everyone, today I'll be talking about 2006 AMC 12B Problem 25. The sequence A1, A2, etc. of non-negative integers is defined by the rule an plus 2 equals the absolute value of an plus 1 minus an for n greater than or equal to 1. If A1 equals 999 and A2 is less than 999 and A 2006 is equal to 1, how many different values of A2 are possible? To solve this problem, let's begin by showing that the GCD of 999 and A2 must be equal to 1. And this is because if we can use a proof by contradiction. So if we assume that D equals the GCD of 999 and A2 and it's not equal to 1, um, that means that D divides A3 since that's equal to the absolute value of A2 minus 999. And then A4 would be the absolute value of A3 minus A2, which D would divide A4 by the same reasoning, and so on until D divides AN. So for all AN pretty much, you can continue this process. And because D doesn't divide A to the 2006, since 2000 A to the 2006 is 1. So that contradicts with the fact that D must divide all the ANs. So we know that D must be equal to 1. Okay, now let's also prove that A2 must be odd. Let's think about what happens when A2 is even. So if A2 is even, then A3 as would be odd, and then A4 is odd minus even, so it's odd, and then A5 would be odd minus odd, so it's even. So this would continue in a pattern of odd, odd, even, except it's disrupted by 2 for the first two terms, because the first two terms would then be odd, even, and then odd, odd, even, odd, odd, even. So because 2006 is equivalent to 2 mod 3, that means that A to the 2006, it must be odd, so it can be 1, right? But if A2 is even, then it wouldn't like fit with the repeating sequence. So A2 must be odd, in which case it would work. So now we have two conditions. A2 is odd and co-prime with 999. So we can use Euler's totient function to compute the number of values that are co-prime with 999. As the factors of this are 9 and 111, so 3 and 37. So this would be equal to 648. And then because we only want the odd values of those, then we do 648 divided by 2, which is 324. Thank you.